Welcome, guys, to today's session. We'll be continuing where we left off. So let us continue. Let's start with question 2. So write your answers to the following. Number your answers from A to J. So that means we have to number our answers from A to J, right? So we have to use the letters that you're provided with. You see here they said A, and then B, and then C, and so forth. So we have to answer it like that. And these are answers for question 2.1. So that's what I'm going to do. I'm going to let me increase the font. Okay, let me make it 20. Yeah, so 2.1, we're gonna have A for 2.1, and then let's see. So complete the following code in which a generic grade class acts as a container for one-dimensional data of type row T. So basically what happened here is they created a class. That acts as a container for a one-dimensional data of type row. Yeah, so we have the row header file. As you can see, there's a hash include row.h. So that means they did implement this. It's a whole class. The row is a class on its own, but it's going to be a generic. We're gonna use that class. So basically what happened here is that with the row.h, they created a one-dimensional array, and then it's going to be represented by this class. Then they use that one-dimensional array to point to it and have a two-dimensional array. I think they were working with the indexing operator. Yeah, this one. So with this, they wanted to work with this indexing operator. So yeah, so remember the indexing operator. If you want to achieve like a two-dimensional array for the indexing operator, you would have to you'd have to create a class that overrides or that implements this one-dimensional operator. Then you use that class and you point to that class, so that now it's going to mimic a two-dimensional array. And then after pointing to that class, you're going to have this operator inside of this class again, because remember, you want to achieve two-dimensional. You want to create an operator that for indexing into a two-dimensional array. So what am I looking for? Notepad ++. So yeah, so as I was saying, so you're gonna have something like this. So let me change the language to C++. So you're gonna have something like this, right? Class, and then row, right? It's called row. That's the class. And then this class is gonna have public member variables and private member variables, right? So okay, let me just save it under here. Yeah, that should be fine. So you had, for example, it's managing. Let's say it's managing it to you're supposed to create a class that manages a two-dimensional array of integers. Let's not make it complex. Let's say you're working with just integers. You're not working with, for example, colors, RGB, none of that. It's just integers. So I would have this one called row, right? And then I would also have an operator here that overrides, right? So remember, working with integers. So the operator that I would have is going to return an int reference, because it's going to you could, I mean, technically you can just leave it like this, it's still fine, because at the end of the day, when you're indexing, you want to get an integer, right? But we tend to use the address of operator, and you can also double check in your textbook. It is there. So let me just show you in the textbook that it is there. Operator overloading. Let me do this. Come on. Okay. Let me just let me look for the page number. Classes, inheritance, pointers, virtual functions. Okay, so it's around 893, somewhere there. Okay, there we go. So let's see. Indexing operator. Okay, just give me a sec while I look for this indexing operator. I'm sure they did provide different ways, and like at least 2 ways on implementing it, because there's always more than one way to solve a problem. Nah, it's none of these. Stream insertion, stream extraction. Okay. Okay, that's the assignment operator. Okay, increment and decrement, post and pre. Okay, there's non-member functions. It's not what I want. Operator overloading. Okay, let's see if they did implement it here. Okay, I don't see it. Or maybe it's towards the end. Yeah, okay, yeah, there it is, towards the end. So, yeah, as you can see, you must return the type by reference. But I mean, technically it is okay to just return it as it is. It's technically okay. It's fine. You don't have to. Yeah, you don't have to worry about returning it by address. But with returning it by address, I would say it's more efficient. It's more faster, and yeah, it makes your application way faster. So there's 2 ways of declaring this operator. You can declare it in such a way that this array it can be changed, so you can assign a value. So let's say you're indexing into the array, right? And then for that index, you can also do this, change the value of that index. So that's why you don't see the const at the end here. That means I can change the array at that specific index. And then here, when you see the const at the end here, it means that this type that I'm gonna get back, this value that after indexing, the value that I get back, it shouldn't be changed. So that means when I index into the array, I cannot change the value at a specific index. Basically, I cannot change the array. Those are the 2 different ways. So just for the sake of accuracy, correctness, just use the address of operator. This address of operator or symbol when you return the type. It's way simpler that way, and it makes your application way faster. So we're gonna return the int reference, right? and then I'm gonna overload what operator? This operator. And then I'm gonna put a const at the end, because remember the const at the end, it means that whatever information I'm taking in here via the parameter, it shouldn't change my array, right? That's what this const stands for here. And then here, this type, I didn't put any const there. That means I can change whatever is being returned. So yeah, those are the two different things. Because if you remember, when we created like accessors and getters, what is accessors and mutators? With accessors, we put a const at the end, right? Because I was only just accessing. I was not supposed to be changing the rows. It's only meant for access. The same thing applies here. It's meant for access. The indexing operator is meant for you to index into the array or access the array. That's it. There's nothing more or less to it. So imagine it was like this, right? This is the row class. Remember that with this operator, right, you cannot take in two parameters like this. You can't say int row, int column. And then let's remember that when you have a two-dimensional array, right, you'd have maybe something like this: pixels, row, column, right? So as you can see here, there's only one. So that's exactly how it works. You cannot put more than one. And the parameter, since you can only take in one of the square brackets, that means you can only take in one integer, because you're indexing into a one-dimensional. If you want it to be able to work with two-dimensional, you have to use some sort of a trick. So you create a class that uses this operator to index into a one-dimensional array, and then you use this class within your other class and make a pointer to it, so that it can become a two-dimensional, so that it can be indexed into a two-dimensional array. So that's why it kind of gets confusing, but it's not really that hard. Just know that you can only use one square brackets. You can't also do this. Come on. Okay, let me just write them like this, that they are clear. Yeah. You cannot write two square brackets like this. You'd be like, oh, but I want to index into the row and column like this. Nah, you can't do that. That's just how C++ is. You can only index into a one-dimensional. If you want to index into a two-dimensional, that means you have to create a class separately that implements this operator to index into a one-dimensional array. Then you make a pointer to that class so that you can be able to index into a two-dimensional array. So yeah, just keep that in mind. So if you look at the question paper, right? If you look at where is it? Where did I see it? Okay, here. If you look at this part here, as you can see, we're putting this next to row, meaning that row class is generic. It's a template. So I would have to make it a template here and say template, and then I can either say type name T, or I can just say class T. There's two ways of doing it, but then the preferred approach by most people is type name, because you might end up confusing yourself. Like, okay, class row, so I'm also taking in another class, or what's going on? So you end up getting confused because of that. So it's best to just use type name. That's the simplest way to go about it. So since I have a T, that means it works with any data type. That means I'm gonna remove this int and put a T there. Remove this int that I'm returning, put a T there. And then remove this. Okay, the indexing is fine, because yeah, the row is going to be of type integer. It's not going to be of any other type. So I cannot just put there T. because I can't index, I can't use a, yeah, you can, for those people who know the advanced topics, yeah, you can index using a string or a character. That has to do with data structures and algorithms. That's a different topic. But here, according to what we're doing here, we're creating a class that has to index into a one-dimensional array. So indexing, obviously, the rows and columns are always going to be of type integer. I can't suddenly put a t there. You're not going to use a dub and say go to row 1.2. There's no such. Or go to row hello world. Since I put a t there, if I put a t there, that means you can even take in a string. You can also do that. So just make sure don't make that mistake. Whenever you're indexing, whenever you have to index, it's always those ones are always the integers. The only thing that changes is the array, the value of the array. We are making this class generic so that array can work with any other type. Don't worry about the indexing and all the other things. Only change the type of the array. So this is how it looked, right? This is how UJ, the row UJ row or row class looked. So now we have to use that class to point to it like this. You see, we have to use that class inside of the grid class. So inside of our grid class, we're gonna have obviously grid class will also be, what is this, will also be generic. So I'm gonna have class and then grid like this, right? I won't write all the other code. I just wanna write the simpler, straightforward parts. So we're gonna have this operator, right? Remember that it's supposed to return some value and then take a reference of that value, and then operator, and then we take in some index, and then const at the end, because I do not want this operator to change that value, to change anything, to change to change where I'm indexing the array that I'm working with, because it's meant to just access, right? So it's gonna be like that, and then I'm gonna have a private member variable. So remember what I said. This operator you can only use it working with one dimensional. So what I said is that the solution to solve this problem is to create a class separately that uses this operator to index into a one-dimensional array. Then we use that class as a data type, as a data type inside of this class, and then point to that class. Then therefore we can achieve two-dimensional array indexing. So I'm gonna have row and then underscore row. I'm just gonna call it underscore row. But remember that the row class is generic. So I would have to tell the compiler that just for now, just know that it's gonna take in some type. I won't provide the type yet. It's gonna be provided inside the main.cpp, but just know it takes in some type. So yeah. So now we need to ask ourselves, this operator, right? It's supposed to achieve this. I'm supposed to have something like, okay, let's say values, right? Okay, remember that we need to make it a pointer like this. You could also technically just make it two-dimensional pointer like this, still fine. So yeah, we'll just make it let's just make it two-dimensional pointer like that, and then we're gonna need the rows and columns, and then we have that, right? So what I want to achieve, okay, I shouldn't call it row, let me just call it my grid underscore grid. So I want to achieve something like this, underscore grid for the specific row, the specific column. That's what I want to achieve, right? That's the objective here. So what value, the question is what value will be returned. So if you check, the value that's going to be returned is going to be this row, because remember that whenever you're working with this operator, it's the type of the array. You see here there's a T, it's returning a T reference because the type of my array was what? T. It was of type T. Here my array is of type what? Row T. So that's the type that I'm going to use there, like this. So this is basically how we're going to achieve the indexing into the two-dimensional array. We're going to achieve it like this. So I'm going to use, remember that this first array is going to be indexed by this operator, and then the second part is going to be this. It's going to be indexed by this operator that I've created here. Then now we achieve the indexing into a two-dimensional array. So basically this is how it looks behind the scenes, even though they didn't give you the row class, but that's how it looks. So just keep that in mind. That's how it looks. So we have this and this. So let's go back to our question paper and see what else we need. So let's start. So if we look at A, obviously we are using a template to create a generic class. And if you remember how we create templates, you say template, and then you put the less than symbol, and then after the less than symbol, you put in type name or class, then followed by that type, whatever name you want to give it. T is very straightforward, it's very short, easy to remember. And then you put the greater than symbol. So we actually know the answer there. So the answer is going to be type name, or you can use the class keyword. It's still a correct answer, because at this point in time it's just you answering questions for a theory paper. You're not literally coding, so you can't say okay, but you said using the class keyword is quite complicated. You might forget that you're actually working with the template and things like that. Yeah, well, that's true, but you're not coding here. You're just answering a theory paper. And then here we have grid. There's B and then there's grid. If you check here, what do we have? I have a public access modifier to state which of my data and properties are public, and then I have my private access modifier. Then I have a helper method, because it's private, obviously means that it's meant to help. It's a helper method. Then I have this two-dimensional array. Then I return the length. Okay, so obviously, if you remember when you talked about data types, like defining your own data type. So defining your own data type, remember that you can use struct. You can use struct to create a new data type that only works with data or variables. You can do that, right? And then you can have class keyword to say that define a new data type that works with both data, variables, and properties. Properties meaning functions. So this is the common ways of creating a type. You can also, if you remember, but since we are doing object-oriented programming, type def doesn't really apply in our case. Remember, type def, it's also defining your own type. It's in the word itself. Type stands for data type, Def stands for definition. So I'm defining my own data type. So type def also does work, but type def is it doesn't apply to things like object-oriented programming right now. Like we're not worried about creating a new type, whatever. Defining our own type using type def. We don't want to worry about that at the moment. So at the moment, just only look at these two keywords. So struct means create a new data type that works with only data. So in the record structure, I should only have variables. Let's check if this is the case for our question paper. Do we only have variables? Okay, I see a variable here, rows. There's a variable here, rows. There's a variable here. Then there's a variable here. It's a constant, but it's still a variable. Okay, but then now I'm seeing functions. Okay, there's this operator function, get rows functions, get calls function. Okay, so now I have two things. I have data and functions. I have variables and functions. When you look at it, which one is more applicable? It's the class keyword, because the example that we're given, it has both data, which is your variables, and properties, which is your functions. You see, there's a function here. All of these are functions, and it even has constructors to show you that, okay, this is indeed a class. So yeah, I don't have to think about this one too much. The answer for B is class. And then C, so let's look at C. Okay, C, now we are sure it's a class. That means there's a constructor. So this is the no args constructor, or parameterless constructor. Then this is a parameterized constructor. Basically, it has parameters. Then I have this funny looking constructor with the const. Then there's an object that is taking in, okay, object original, but it's still a constructor. So if you remember the constructors that we have, the different types of constructors that we have the, okay, let me do this. So we have the no args. No args means no arguments, and arguments are just parameters. So it means it has no parameters. No args or no arguments constructor. That's the first type of constructor that we have. Then we have the parameterized constructor. Basically, it has parameters. That's the second type of a constructor. Then we have, if you remember only in our previous sessions, we have this other type of builder who is very lazy, likes to copy from other people. That's the copy constructor. This one likes to copy from other people. This one is what we call the lazy builder. Remember that the constructors are just different types of builders. And these different types of builders, they have parameters, right? So they have requests from clients. They have requests from clients. Parameters is just basically clients telling them, okay, I want my house. For example, let's say the constructors or the builders are supposed to build a house. So the parameters that they would take in, obviously we're going to have a class called house. Then we're going to define the different builders. So obviously they're public, these builders. Everyone has access to them. As long as you have the right resources, you have the money to pay them to build the house for you. In our case, we're building a house. So there's going to be the first builder, the one with no arguments, with no parameters. So this one does not take, remember that what goes here is basically requirements from clients. Remember, these builders are meant to build, right? So whatever parameters you're passing in, it's basically requirements from the clients. The one with the no parameters is basically the type of client who doesn't care how their house looks. All they want is a house. They don't even care how big it is or how many stories it has. Just build a house. That's all I need. So this builder doesn't need to know any other information. So this builder is gonna work with default values. That's what this builder is gonna work with. Any values or any size that they think is good enough to build a house. That's what this builder is going to do. No, it takes in no requirements from the clients. Then the parameterized constructor is the one that takes in requirements from the client. This one, the client is going to specify how big. So let's say rows and columns. So they want to specify the length and width of the house, how big they want it to be. Then they would also maybe give you a extra information. Maybe they want a specific color, so it must be of some specific color. Maybe they want the house to be black from the outside, blue on the inside, any color, or pink from the outside. That's what this requirement is. That's what this parameter stands for. It stands for the color that the user wants. So all of these parameters, it's requirements from the client that this type of builder is building for. So this type of builder builds for those clients who are going to provide information. So for example, they're going to tell the builder, I want it to be this wide, I want it to be this high. So they'll specify the width and the height, how many stories, the color of the house, all of that. That's what they're going to specify. And then we have the other type of builder. I like to call this one the lazy builder, but at the end of the day, it's basically the client who's telling the builder what to build. So this one is, but at the end of the day, he's also still lazy because he could be as efficient as the other ones. The one who takes in requirements, the one who takes in no requirements, he could be as efficient as them too, but he's just lazy. So this one takes in requirements from a client, and usually this one takes in clients who want to copy from others. For example, your cousin sees a beautiful house when they along their trip. Maybe you guys went to Zanzibar or whatever nice fancy place you went to, or Dubai. Then your cousin saw this other beautiful house, and then your cousin took pictures. And then when your cousin comes back, he's gonna show pictures to this type of builder and tell this builder copy from this. So he's gonna tell this builder to copy from this. So when you're building a house, just copy from that house. So all the dimensions and all the whatnots, the colors and everything, it's gonna be copied from that another existing house. So basically this means copy from this house. Basically copy exactly the same way this house was built, and build my house for me. Even though you're gonna become twins and have the same house, but yeah, this builder basically what his job is to copy from other people or from other builders. Remember that house that he's copying from, another builder built it. So obviously he is copying from another builder. He's a lazy builder. He can't think of something unique, but it's not his fault because he's getting requirements from the client. So obviously, if I'm building a house, if I'm copying from a house, I must take in a house object because I'm copying from another house. And this house is gonna give it a name. Let's say OBJ house, right? And then you know that whenever I'm copying from this house, I want to take it by reference to speed up things. I want to actually go to the address and copy that house from that address, instead of actually copying the address, the house itself. So imagine it's like if you don't put the reference, like what you're trying to do, you're trying to literally remove that house from there to where you are, well, to where you want to build, of which you can't do that. You'd have to go to the address and see how it's built, then come back and after inspecting how it was built, then build it. You can't take somebody's creation and put it and make it yours. So yeah, that's what you're doing. Obviously, when you go to copy and see that person's house, you don't want to make any changes, right? You can't change someone's creation that you don't have any ownership over that creation. It's not yours. So obviously, when you go to inspect and copy, you don't want to make any changes. You don't own it. It's not yours. So that's why you want to put the const there to say that this is a constant. It should be constant. It shouldn't be changed. This object that I'm copying from, I should not have the privilege to change it because I do not own it. So as you can see, these are the different types of constructors that we have. So now we're going to go back to the question and see which constructor they're talking about. Remember the first constructor, I was just making notes here. So it should actually be like that. I was just making notes. So these are the three types of constructors that we have. So let's see. As you can see, it's the one with const. So obviously I need to take in copy another grid, but then I shouldn't copy the grid itself. I should go to its address where it's located. As you can see, they've already declared obj original. I don't have to declare that. So the only thing that's missing here is grid reference. So the only thing that's missing here is grid reference or grid address of, or address of grid. And then yeah, they're just covering this out. But at the end of the day, if you highlight properly, you can see the answer. If you check, you see type name. There it is. It gets highlighted. Yeah, they didn't cover it properly, but yeah, they just wanted you to make sure that they don't give you the answer for A, because at the end of the day they want you to fill in A. So if they write here, you're gonna see and be like, oh, okay, it's type name, I remember now. Whereas you actually don't remember. You just got lucky, they gave you the answer. So now we have the OStream operator, right? We have to answer letter D. We can see it returns an OStream reference. There's OStream reference, there's const, there's this. Okay, let's investigate what's going on there. So if you remember what he talked about, right? The house, let me see, what did I want to talk about again? Yeah, the class keyword. Remember what he said, the class keyword means create a new data type. So just like with all the other data types, the pre-installed data types, like your int, your long, your short, your byte. Okay, it's short. It's called short. Your long, your float, your double, your char, your wide char. I think it's wide char, something like that. Yeah, wide character. All of these data types, they're already created, right? So whenever you create any variable of any of this type, there's operators that it works with. What are these operators? For example, I can say int num, right? And I say is equals to 1. This equals to symbol is what we call an operator. So let me just give you a list of some operators. So some of the operators that we have, it's equals to plus, minus, plus plus, minus minus. You can have, what's the other one? The stream insertion operator, stream extraction operator. You can also even have a combination of plus and assignment. So plus equals to, minus equals to, divide equals to, modulus equals to. You can have all of these operators. They're infinite. There's a lot of operators. So you can define operators. So by default, these data types that we have, they work with the operators. So that's why whenever we create our own type, we have to define and create these operators to work with our type that we've created, because C++ does not know that type. C++ does not know that type. So you have to do operator overloading. So that's the concept that we're doing right here. It's called operator overloading. So okay, I won't create any class. I just want to show you the thing that I'm talking about. So we have int num is equals to 100. So if I build this, it's not going to give me any issues, right? Because this operator, it has been already implemented for me for this type called int. So you can imagine behind the scenes there's something like this, class int. You can imagine that's exactly how it is behind the scene. Class int, and then you can imagine the assignment operator. There's an assignment operator like this, which takes in an integer, because I'm working with an integer, so it's going to take in another int like that. So you can imagine behind the scenes is like this. There's a class called int, basically a type called int. Because why am I saying so? Because if you say num dot, okay, but yeah, just imagine something like that behind the scenes. Just imagine it's something like that behind the scenes. So we have that type, right? And then remember this type num, it also works out with standard output. So it works out with cout to output the num like this. And then I can build and run. And then there we go. There's my answer. I can build and run, and then I get the answer of 100. So it does work. This operator does work with this type because it was defined in the class, or it was predefined for me. Let me see, declaration. Yeah, I was just checking here. Let me see, go to implementation of. Okay, so it only shows declaration. Okay, it doesn't show. Yeah, but just know behind the scenes, this operator works with this, anything of type int, of that type, or even long, or even double, any other type that comes pre-installed by C++. So yeah, now the question is, what is this? If you check, okay, I don't have to open, but if you check here, if you hover it, you see it's type ostream, standard cout. So it's an object of this class, of the ostream class. And then on this right hand side, what do I have? Int. It's of type int. So basically on the left hand side I have ostream, and then on the right hand side I have int, like this, right? If you don't believe me, we can open the hash include to see what type is cout. Okay, so let's see. There it is. What is the type of cout? It's ostream. Just don't pay attention to this. Focus on this from here to here. It's ostream cout. It's of this type. So that means every time I want to output something, I have to make it of this type if I want it to appear on the terminal. As you can see, it's called what? The standard output. So let's talk about what ostream is. O stands for output. and then stream stands for stream. So it's for the what, and then since it comes with C++, we call that we say that it's part of the standard. That's the standard C++. So in full terms, it's gonna be called standard output stream. So it's a standard output stream, basically meaning that you can output text onto the terminal. So I can build and run like this. Okay, I can build and run. Why is it that when I build and run, why isn't it zooming in now? But yeah, if I build and run, you can see that that value 100, it appears now onto the terminal. And how did I achieve that? I use the standard output stream. So what happened? Let's understand what happened. Cout, basically, in short terms, we can say it's console output, or the most commonly used term is character output. So basically output characters. So that out stands for output. So it's like this. You put a space there. Out stands for output. And then C stands for character or console. By console, it's another term for terminal. That's what console means. It's another term for terminal. So basically what I'm saying to the computer is output characters to the console. That's all I'm saying. Or let's just say it's characters. Let's put it in that way, because I want to break down how this happens. So you can imagine it's like Cout represents the terminal, right? This is your terminal here, right? And at this moment it's what? It's empty. And then now this stream insertion operator, as you can see, listen to the term insertion. What am I doing? I'm inserting, or I'm putting into something. I'm inserting, right? So how does it work? So it's gonna be like this. This is the operator. Remember, when you put the variable here, what happens is that it takes the value of which that variable holds. So then the num variable, it holds the value of 100. So it's gonna put 100 there. And then now what's going to happen, right? At each iteration, this is what's going to happen. It's going to say, by iteration I mean at each step. So it's going to say terminal, it's going to push 1 into the terminal. So it's going to have a 1 there. And then now there is 0, 0 left. 1 has gone into the terminal. And then now, remember, that's why they're calling it character, because it breaks down everything into characters. It inserts it one by one. And in my case, I'm inserting an integer, which is, and you can see there's no spaces in between them. So I'm inserting into the terminal like this. Remember, look at the arrows. The direction is very important. It means take these characters and direct them to this terminal. So it must input one character at a time. That's why they call it Cout, character output. So I'm outputting characters, and it does it so fast to the point that you think, okay, it inserted everything all at once. No, it inserts one by one. So I'm gonna show you another example. So as you can see, it has inserted 1. Now the next value is what? It's this value 0. So it inserts 0 here. And then remember, in the current value of 100 of num, there's no spaces there, or there's no dot. It's not a double. There's nothing there. So what it's going to do is going to insert that 100 one character at a time. It starts by inserting 1. Then obviously you're left with those 2 zeros. Then it inserts this 0. Then you're left with this 0 at the end. And then the last iteration is going to insert the remaining 0. And then now, you see, there's nothing else to put. But then we're going to extend on this. extend on this to show you. As you can see, there's the 100 today. The 100 does appear. So now what I'm going to do is I'm going to also output. As you can see, this thing is very analytical. Be careful how you're outputting. So let's say after this, remember that the output right now is currently just 100. Let's say I wanted to output some space and then say hello and then a comma and a space and then say world. So what's going to happen is going to insert all of this in the specific order. So we're going to continue where we left off. Come on. We're going to continue where we left off. Okay, no, I just want to do this. Okay, let's just continue from here. So as you can see, it was like this, right? So there was nothing else to insert. But then now there's still more to insert because I've used the stream insertion again. So what did I tell it? What did I tell it to do? Insert it like this. It's going to insert it exactly like that. It's very literal. So yeah, just keep that in mind. So it's going to do this, go to the terminal and see what's the next available character. It's this space. So it's going to put that space there. There you can see the space is there. And then in the next iteration, it puts, remember that we have a space now. What should come after the space? It's an H. Then it puts an H there. Yeah, you get the idea now. Then it puts an E. There's no space. And then it puts an A, an L. And then it puts another L. And then it puts the O like this, right? And then what's after the O? It's the comma. So it's gonna put the comma, hello, comma. Remember at this point in time, I'm putting one character at a time. And then it's going to say hello, comma, and then what should I insert now? The space. And then that's why you're gonna have a space there. And then in the next iteration, what should I insert? The character W up until D, and there's no spaces in between. So it's gonna put W like this. Yeah, as you can see, this is a lot of work, but then it does it so fast that you don't even see it. You're like, okay, why? What happened? All I'm seeing is it's outputting what I expected to output, but it does it so fast that you think, okay, nothing is actually happening, nothing fancy is happening. But yeah, this is all it's doing behind the scenes. So yeah, it's gonna have this terminal, and then it keeps inserting each character at a time. Okay, let's just do this to save time. Do a multi-line comment. Yeah. So this is how I expect it to output. Exactly like that. So let's build and run. There we go. Exactly how I expected it to output. So as you can see, that's how the computer works. That's how the stream insertion works. It's exactly like that. It inserts one character at a time. So that's what we're trying to achieve here. Because I saw the O stream. O stands for output. That means I'm working with I'm outputting to the console using the standard output stream. So how did we get about to this level, like all of these things? Why does it seem so confusing? To be honest, it actually makes sense. There's no, even though the syntax might be off-putting, but it's pretty straightforward. So remember how this works. You have, if you remember in math, when you're doing math, x is equals to 1, right? Left is equals to right, right. But then if you think about it in a practical sense, or think about it critically, what's really going on here? What's happening is that I'm saying x is going to be the placeholder for 1. So that means if I create a new variable called y, and the answer for y is x plus 1, therefore y is going to be 1 plus 1, which is just 2. How do I know the value of x is 1? Because of that at the top, that assignment. This is what we call an assignment. I'm assigning a variable a value. So it's assignment. And we are using an assignment operator. So usually when you have things like this, when you have x is equals to 1, the value on the left hand side, right? Let me put some spaces. So the value on the left hand side, we call that the left operand. Basically, values that we are working with to manipulate them, they're called operands. It could be a variable, anything that's on the left and or right hand side of the operator, then it's an operand. It's basically the thing that we're operating on. Imagine a doctor doing operation. It's exactly like that. So we are this operator is operating on these two things, the left hand side and the right hand side. So the only difference is that this one is the left operand because it's on the left, and then the thing that's doing the operation is the operator. So the operator, you can imagine, for example, that's the doctor who is operating the two things. And then on the right hand side, we just gonna call this the right operand. That's exactly how it's going to be all the time. Even if when you have something like this, you have C out, and then you have the operator, the doctor, that thing that's operating on, that's doing the operation. We call that the operator. Basically, in our example, I'm using the doctor. The doctor is the one who does the operation. So the doctor is the operator. Then we could have an int here, or in our case, we can have a house, right? So it's like this, right? So just bear with me. Be patient. We're gonna get there one step at a time. We're gonna get to the function and how it's created. So obviously, if this is the rule, that means I must create a function, right? Operator. Remember that when you use the keyword operator, it's just a function. So what's the function called? It's operator. That's how the function is called. And to show you that it is actually a function, it's just that it's way simpler to write this function in such a way that it's similar to maths, because with maths it makes a lot of sense. You're like, oh, x is equals to 1. Imagine if they had written it like this: x dot, remember I said it's a function, so dot operator equals to, and then I say 1 semicolon. This is allowed. It's 100% allowed. But then this is like the shorthand or the shortcut of writing this. So as I'm saying, operator followed by the keyword operator followed by the actual operator. It could be an equal sign or the stream insertion. That's a function. That whole thing is a function. And as you can see, it should take in some parameter. This one is taking in an integer because x is an integer. So obviously, this one's going to take in an integer. Like that. So with this one, we want to insert into the terminal, right? So that we can see our object. So in our case, let's forget about the house example. Let's look at this grid. It's called grid, right? And that's all I need to know. I don't need to know any other information. As long as I know it's called grid, that's enough information for me. So it's gonna take in So basically, this operator, the way it's going to work, you're gonna pass in the operands. You can to not be confused. It's best to start with the left one and followed by the right one. You could pass them in any order, but okay, not yeah, you could, but yeah, it's gonna be very confusing if you pass them in any order. So start with the left operand. So what's on the left hand side? It's C out. So now, okay, let me remove this so that it becomes very clear. So let's say we have some object grid, right? Some object that we want to output. So remember this, in shortcut, this is what I'm trying to write. So I want to be able to output the grid, right? Like this. But I'm just leaving it like the space is there so that you know what the left is called, what's the operator called, what's the right operand called. So we have this. So obviously C out, the left operand, right? C out is going to be, what's the data type of it? It's OStream. And then what's the data type of obj grid? It's of type grid, right? But then remember what I said, it's way faster for you to access information by getting the address of it, right? So I'm gonna say get the address of each of the inputs. So obviously you can see that C out of that type OStream is on the left hand side. So I'm gonna take in OStream by reference, and then I'm gonna remember this is the left hand side, right? I'm gonna call it left hand side like this, and then remember you can't use C out. I can't say C out like this. It's already declared in C++. It's gonna complain. It'll be like, it's already defined. What are you trying to do? So when you write it like this, in essence, what you're trying to do, you're trying to say int. You can't use int as a name because it's already owned by somebody else. So that's the point I had to raise there. So you might be tempted and be like, okay, but it does work the same way C out. Yeah, it does, but come up with your own name because you are inventing it. And then on the right hand side, I want to output of the grid reference. So grid on the right hand side, yeah, I'm gonna call it right hand side. Yeah, I feel like it's best to just call it like this. Don't not complicate things. So I have this, but one thing that we need to be very careful of is the obj grid. When you're outputting, do I want to change the information of the grid? No, I don't want to change it. So I'm going to put that prefix, the const prefix there to say it's constant. Whenever I try this, remember what stream insertion means. I'm only inserting into the stream. I'm only inserting the characters on the terminal so that the user can see them. I don't want this operator to mistakenly change things that it's not supposed to change. It's only meant to output. That's it. So that's what this const does there. And then obviously it must return the OStream object. So it's gonna return an OStream object since I'm inserting to the stream. Obviously that's what's going to be returned, right? What you see on the screen is information from the object from the output stream, standard output stream, right? So obviously I have to return that I have to return the OStream. I have to return the OStream because I have inserted into the OStream. So after inserting into the OStream, I need to return it. And then remember that this operator, it's a bit weird. It's a bit funny because compared to other operators, it doesn't allow you to use it like this, just like it's yours. You have to put in the friend keyword and say, okay, this is my friend. Yeah, I know he's gonna act as a friend. I'm just gonna borrow his ability to do this. Yeah, I don't own it. This is my friend's work. He's the one who's good at outputting, so I'm gonna borrow his ability to output. And remember, always when you returning things that are going to be big, just normalize returning them by reference. So this is going to be returned by reference. So this is how the operator will look when it's full, when it's complete. So let's check what's missing in the code. Yeah, it's after const. Okay, there is the object right hand side. As you can see, you see left hand side, right hand side. So const, after const, what's supposed to follow after const? And I forgot, this class is, it's generic. Yeah, I think some of my answers might be incorrect. Yeah, it is generic. So that means every time you write grade, you have to specify that it takes in some type. So it has to be like this. Yeah, sorry, I forgot about that. But yeah, this is it's very important. You should put it there. I don't know how I forgot about it. Yeah, I guess you get caught up in the explanations and forget. Yeah. So obviously this grid is not just any grid. It takes in any type. So I have to tell it that it should take in any type. Obviously, if you saw on the code in the question paper, the only thing that was missing is the grid reference. This part of code, that's the only thing that was missing. So inside of my answer sheet, I'm gonna write this again. what a coincidence. Yeah, don't ever look at this and be like, okay, this is weird. Why are they the same answer? Don't start confusing yourself and be like, I don't think it should be a reference. Maybe I should just change it like this. Then you start losing marks. Just write what you know and leave it. Even if it happens that, for example, question 1 was A. Question 1 was A. Question 2 you also got A. Question 3 you also got A. Question 4 you also got A. It's normal. If that's the answer, it's the answer. Don't try to lie to yourself and convince yourself and be like, okay, maybe that's not the answer. The fact that it's similar or it looks the same, it's weird. No, it's not. It's perfectly fine. So yeah, we have that. So okay, no, yeah, my bad. I'm not answering the question. This is just the blocked part. This is where you're supposed to answer. So the thing that's missing here is the operator. It's the less than symbol. That's the thing that's missing there. So it's actually this less than symbol. Yeah, that's the thing that's missing there. But yeah, just make sure you know the whole structure of the stream insertion and the stream extraction. They love to ask those questions because, as you can see here, you see now they're asking for this and this. So you have to know the whole function, how it's declared. So let's go back to the iStream now. Since we've been working with the cout, now let's go back to iStream. It's exactly the same thing. It's exactly the same thing. The only difference is the direction. So now I'm no longer outputting the characters. I am inputting the characters. So cin stands for character input. C stands for character. In stands for input. And then I'm inputting it into let's say into the object, right? Yeah, into the object. Yeah, because we're working with that object. So we have to insert it into the object. As I said, it's exactly the same. So I'm just going to copy this function. The only thing that changes is the stream that you're working with now. Remember that I was working with an O stream. O stands for output, but now I'm working with input. So now I work with I stream. And then everywhere I see O stream, I put an I stream. And then that's it. That's the answer. You're done. So if you know one of the functions, okay, the operator needs to change direction, and then that's it. You're done. If you know one of the operators, you're bound to know the other one. The only thing that changes is the direction and the type that you're returning. One is O stream, O standing for output stream or standard output stream. I standing for input, or in full terms, standard input stream. And then don't forget the direction is important. Since it's input, I get from the console, and then you see the direction it's going into obj grid, so it's input. So let's see what do they want us to answer exactly. So they want us to state the return type. What's going to be, what's missing here? It's the friend keyword, because we already have the iStream reference. We already have it. If you check here, you see we already have the iStream. So what's missing is the friend keyword. Remember that what I said about these operators, right? They are weird. You can't implement it as your own. You have to sort of like borrow your friend's ability to input and output. Just know, input and output you're borrowing from your friend. There's always that friend keyword. So I'm gonna have E, which is gonna be friend, and then F. Let's see what F wants. F is going to be, you see, I suggest you know all of these things. So F, they want you to specify the operator, the symbol. How does it look? So how does it look? Let's see. How does it look? It looks like this, right? I am getting from the user or from the console to the variable or object. So it's in the other direction. So it's like this. And then let's see what's missing. Okay, G. Remember when we did G, we actually did answer this question, but we hadn't gotten there yet. So as you can see, when we made that example about the row class, we talked about it. You have to return the type of the array by reference. So it's this array, but then remember when you're returning something, it's always faster to return it by address. So what's missing there in G is just the address, because they already specified the type. They gave us the type there. It's row T. All I'm missing is the address. If you check here, there it is. Only thing I'm missing is the address. So that's the only answer that you had to write there. So G, address of. And then let's see if we have any other questions. Okay, yeah, we have age. What is age? Okay, they actually do kind of give you hints. Yeah, they do kind of give you hints. So they're saying this is the grid implementation file. So obviously, if this is the implementation file, and you see they even have that grid underscore age included. So obviously, this is going to be grid.age. Include grid.age, because you'd want to implement, right? So you'd have to say include. Let me see if they didn't. Yeah, there it is. There's the name here at the top. So that's exactly how you should name it, grid. So if just to help you out in avoiding mistakes, even though they won't be that strict, but just always copy the name of the class and then put it .h or .imp or .cpp if that answer requires that question requires an answer like that. Just copy the name of the class. You see grid, it's capitalized. The G is kept exactly how the header file looks. You see. Okay, I see. Yeah. Almost made a mistake here. Yeah. Remember that with implementation files, you don't actually include the header file inside the implementation file. It's vice versa. But yeah, at least now we know. They did give you the name. It's right there. But yeah, you have to understand what's going on. Remember that end if here, that means the header file, I stop creating the header file here. So that means H is going to be this, because remember what I said, it's vice versa. Instead of, if you're working with implementation files, right? So let me clear this out. If you're working with implementation files, right? So if you have class grid like this, and then you're gonna have end if here, and then you're gonna have grid underscore h, right? And then you're gonna have Okay, let's do it. If not defined, grid underscore age, and then define grid underscore age. So this is how it's going to look, right? And then you're going to have your implementation file. So this is going to be your grid.implementation file, right? Just know it's going to have some code or whatever somewhere there. So the way it works, right, unlike the usual way of, for example, if you had .cpp, obviously in the cpp file, you'd just say #include grid.h. You just do it like that, right? But then in implementation files, it's vice versa. You actually include the implementation file in the header file. So that's how it works. Because .imp, remember .imp doesn't exist. You made that up. You just called it .imp. C++ doesn't know what .imp means. So you can't include the header file inside .imp. You don't know what .imp is. You don't know how to compile it. You get what I'm saying? So yeah, it can't run that. But anything with .cpp, remember .cpp just stands for the P stands for plus. So it stands for .c plus plus, or in other terms .c++. So it knows, oh, I have to compile C++ code. Okay, yeah, I'll compile it. That's why you include the header file inside this .cpp file. But then at .imp, it'll be like, okay, what do you mean? Basically, this is what is going to ask you. What do you mean by .imp? I don't know what imp stands for. It's not universally known. Nobody knows that except you. So you get what I'm saying? So obviously it's going to be vice versa. You're going to write the implementation in the .imp, and then you after everything, after this class, then you include your implementation file inside the header file, because at least it knows what .h stands for. It knows .h, it's a header file, so it can compile that. It knows it's C++ code. So I'm gonna say #include grid.imp like this. So this is what they wanted for that question for letter H. That's what they're looking for here. That's what they're looking for. Because as you can see, I'm not even done in creating my header file, defining my header file. So as you can see, it's immediately after the class definition. Then they're including something. Obviously, it's the implementation file, because you're working with templates. It's a generic class. So yeah, you'd have to do it like that. So for the letter H, the answer is going to be this. And then what's next? I think there's also J. H-I-J. Yeah, so J. And then here, yeah, there's something missing here. It's something small though that you might forget, but yeah, remember that when working with generic classes, everywhere where you put it, where you define grid, when you call the name of this class grid, it's generic, right? Always remember that it's generic. So everywhere where there's grid, you put in of type T to specify that it's going to take in some type. It doesn't work with one type, it works with more than one type. So this is what's missing, because everything was like this, right? If I'm not mistaken. Yeah, everything is like this, and then they omitted this. So obviously that's what's missing there. So that the less than and then a T and then greater than combination is what's missing there. To see to that states, okay, this is a header file. This is a generic class. So I need to put that there. That's the answer for I. And then what's J? Oh, J is straightforward. I thought it would be a bit confusing. Yeah, it's all about allocation. Don't be fooled by what you see, the type that you see here. It's all about allocation. So if you remember how we allocate, you always say underscore, let's say I called it grade if I'm not mistaken. Then you say new, let's say it was integers, right? You'd say int pointer like this, right? And then you would allocate the outermost pointer, this one. You'd replace each pointer with square brackets, because if you remember fixed sized arrays, you use square brackets to specify the size. So you're going to replace every pointer that you're allocating with square brackets, and then you specify the size within the square brackets. So obvious here it's going to take in some number of rows. And this is always the same. This line of code is always the same. The only thing that changes is the type here. In our case, I was working with integers, but we could be working with something else. So imagine it was like this. So that's why I was writing it like this. But since in our case, in the place of int, there is row of type t, so I would have to go down there and then replace this with this. I just changed the type of the array. That's all I have to change. So now if I look at it, I'm supposed to say row of type t, and then it should have a pointer and then square brackets. So now I have a clue of what to expect, and then I look at it, I see, oh, there's this, and then there should be a pointer following it, then square brackets, and I'm like, oh, wait a minute, the pointer is missing. So J is actually the pointer that's missing. So the letter J is gonna be the pointer, like this. So there we go. These are all the answers that you're supposed to write there. So I'll just stop it here, because I feel like I spent a lot of time in 2.1. But then yeah, it's code. You'd have to really understand what's going on. You can't just be like, okay, yeah, I'll just write it, and yeah, you can't do guesswork here. You have to be 100% sure of what you're writing. So yeah, so far we're done. We did 30%. Okay, not necessarily 30%, because there's this question that we haven't done. But yeah, we'll get to that when we're doing data structures. So yeah, that's it. We'll see you in the next lesson.